Can you all hear me? Can you all hear me?
Yes, sir.
Background so noisy.
Little bit, sir.
Not as per it as earlier, right? Tomorrow we'll find a solution for this. That's it. Keep the video on. Very good. So where did we stop? Earlier? Can I summarize the previous class? Something please help me. Summarizing the previous class.
Good evening.
Yeah. Anyone? Rohit, you can try. Anyone? Rohit, you begin. Can you please summarize the previous session? What did we learn before? What topic we learned?
Can you hear me?
Can you hear me?
Sir, can you hear me?
Rohit, respond.
Sir?
Can you hear me?
Yes, sir. Little bit. I can hear, sir, but some background noise is coming, sir.
Okay. So can you please help me summarizing the previous session?
Yes, sir. Last class, you talked about graphs, little bit of
Okay.
calculus.
Okay.
Sir, we saw about the slope and velocity, uniform acceleration.
Okay.
Then how the velocity and time we saw how it changes, uniformly it changes. We saw three type of graphs, like proportional, inversely proportional.
Okay. Different types of graphs.
Yes, sir. Different types of like graphs. You also seen about velocity time, about the various graphs about velocity at like uniform acceleration, and then like exponents is also.
Okay. So everyone, please keep your video on and keep your video up. Today, we have something called the differential calculus. Before we enter into differential calculus, we are going to learn something very specific about the graph behavior. Shall we start? Can we? So now let's take suppose the background is so noisy, bear with me just for one day. Tomorrow it will be. Fine, sir. So I'm going to introduce some extra information in your graph. Okay? Let's see that. Okay. So here we go. Let's talk about the graph. So here we go. It's a graph. X and Y coordinates. Okay. I'm going to write an equation. The displacement S is equal to ut plus r at square. I hope you remember this equation. I hope you are aware of this equation. Am I right? Simply let's take another equation. V equals u plus at. In grade 9, you must have learned this equation. Am I right? In these equations, what does it u mean?
Sir,
Yes, sir.
sir, can you once again tell the recap of that ut plus half 80 square, sir?
That is displacement.
Formula.
Ut plus half at square. In grade 9, you must have learned it.
Sir,
There are three
learned, sir,
equations.
but I forgot, sir.
Okay, there are three equations you must have learned for uniform motion. V squared is equal to U squared plus 2AS. You remember these three equations from grade 9? Uniformly accelerated motion. Equations of uniformly accelerated motion. Have you learned? If so, I want you children to recognize and tell me what is U. What is U?
Sir, initial velocity.
Initial velocity. Very good. What do you mean by initial velocity?
Sir, what, sir?
Come again.
So, no, sir, you told something, I can't hear.
What do you mean by initial velocity?
So initial velocity is the velocity in which the object starts. So the speed of the object at the starting point is called initial velocity, and the
Very
ending point
good.
is called.
Very good. That is the most important observation. When I start to observe the entire motion, the initial velocity is some value. That means I cannot start my graph from zero. Suppose let's assume that this graph is a velocity time graph. Let's take this graph as velocity versus time graph. On the x-axis I have time and on the y-axis I have velocity. Okay? Can I start this graph according to this equation? Can I start this graph with zero velocity from the origin? Can I start? Say something.
No, sir.
Can I start? We cannot start. So the graph must start somewhere else. See, when I start to observe the graph, that is the time is zero. Already the body has some velocity. And I mark that velocity here. Fine. So from there, the velocity is increasing something like this. Noted? These are the initial variation in any graph. Noted? Suppose if someone gives you this kind of graph, and obviously this distance is going to be your initial velocity. Okay? This distance is going to be your initial velocity. So how do I recognize information from the graph given to me? And obviously from here I can easily calculate the slope, and the slope will give me change in y divided by change in time. So change in y divided by change in x, which is equal to change in velocity divided by change in time. So this slope will give me acceleration. Am I right? Okay, let's assume the condition now. For the same given situation, I am going to give you a small problem. Let's try that out. Imagine in this graph, I want you to find out. I bring it here. This is going to be 5 seconds. This point is going to be 5 seconds. Okay. Noted? And this point is going to be 2 meter per second. So velocity is measured in meter per second. Time is measured in seconds. And obviously, in this entire case, the acceleration is positive as well as constant. Correct? According to the graph. Is that right? Say something.
Yes,
Yes,
sir.
sir.
Okay, good. So now I want you children to find out what is the final velocity. I want you children to find out what is the final velocity. Suppose let's imagine. Okay, you try. And let's assume that a ball is dropped. Okay, a ball is dropped like this. This is the condition for which we have drawn the graph. So what's the acceleration acting on the body? Acceleration due to gravity.
Sir,
Oh, that's it? Yes?
sir, the 5 seconds is what, sir?
5 seconds is the time. I want you to find out the final velocity. Watch this. The U is marked here and the
Yes,
V
sir.
is marked here. You watch
Ah.
this graph. The graph நமக்கு என்ன தெரியுது பாருங்க. Velocity இந்த இடத்துல ஸ்டார்ட் பண்ணுது. கொஞ்சம் கொஞ்சமா இன்க்ரீஸ் ஆகுது. And இந்த இடத்துல ஸ்டாப் ஆகுது. கரெக்டா?
Yes, sir.
அப்படிதானே பார்க்கணும் இந்த கிராஃப?
Yes, sir.
அப்போ இந்த இடத்துல என்ன வெலாசிட்டிக்கு பேரு? இனிஷியல் velocity.
Initial, sir.
இந்த இடத்துல என்னன்னு பேரு? ஃபைனல்
Final.
velocity. அப்போ ஃபைனல் வெலாசிட்டிக்கு நான் டைம் கொடுத்திருக்கேன் உங்களுக்கு. அப்போ 5 செகண்ட்ஸ் ஆகும்போது ஃபைனல் வெலாசிட்டி எவ்வளவு இருக்கும்? 0 செகண்ட்ல இருக்கும்போது இனிஷியல் வெலாசிட்டி 2 மீட்டர் per செகண்டா இருந்தா
Sir, 10, sir.
ட்ரை பண்ணலாம். We don't know. Let's try. Let everyone also try. So did you understand the question? If the initial velocity of a ball, which is accelerated at the rate of approximately 10 meter per second squared. Okay? It's because when I drop it, acceleration due to gravity is acting on the ball. So let me write a few more information. So the acceleration acting on the body is given as acceleration due to gravity g, which is equal to approximately 10 meter per second squared. 10 meter per second squared. Okay? Then sir, initial velocity is given to me. How much is that? 2 meter per second. And the time is also given to me 5 seconds. Now it's much easy to find out the information. Yes. Someone has sent a message. Let's see that. So what's the formula that we have for a uniformly accelerated motion? The final velocity v is equal to u plus a into t, which is equal to u is 2 meter per second plus acceleration due to gravity is approximately taken as 10. Correct? And multiplied by time required is 5 seconds. So put together it is 2 plus 50, which is equal to 52 meter per second. So the final velocity would be equal to 52 meter per second. Got it? This is
Sir,
how, yes,
sir, the G is equal to 10 meter per second, like it will be provided in the question,
second
or we should
square.
assume?
Second square. So it is universal constant, right? So not universal constant, it's a known constant, right?
Yes, sir.
Suppose if they say the body is under the influence of gravity, then you are expected to take that. Noted?
Yes, sir.
Otherwise, in any regular case, the acceleration will be given. Otherwise, you can find out the acceleration using some other information. We can do that too. Shall we try?
Yes, sir.
Let's try that problem also. Once, if you are done, if you have copied it, we can move on. Shall we? Now I am going to teach something called intercept. What is that? Intercept. There's a concept called as intercept. Okay? Let's imagine a situation here. You can imagine the situation here. You are observing a person. Okay? He started from his house and is going to a park. Started from his house and going to a park. Okay? Fine. Yes. So from his house to the park, it is 6 kilometers. Let's assume that. The total distance is 6 kilometers. He has to travel 6 kilometers. Okay? And imagine that he is walking steadily, not slowing down, not speeding up. He is walking steadily. Okay? This is the situation. Okay? You are standing at a point at your house, let's imagine. So this is that man's house. This is your house. And this is park. What is the total distance? 6 kilometers. Okay? Got it? Got the idea now? So when he crossed this place, you observed him from your house. Fine? Okay? You know, from your house to the park, the distance is 4 kilometers. The distance is 4 kilometers. Okay? Okay?
Yes, sir.
And he is walking at steady rate. This man is walking at a very steady rate. This man walks at a steady rate. So you observe him. He reached the park. He reached the park in 1 hour. He reached the park in 1 hour. From the time when you started observing. The time when you started observing. Okay, he took 1 hour to cross from your house to the park. Okay, you guess and tell me when he could have started from this one. You guess and tell me.
30 minutes.
Yes, exactly. He might have started 30 minutes ahead of when you started to watch it. Am I right? Correct? எப்படி ஏன்னா இந்த டிஸ்டன்ஸ் 4 கிலோமீட்டர் இதை 1 hourல போறாருன்னா அவருடைய ஸ்பீட் ஸ்டடி இதுக்கு அவருக்கு எவ்வளவு நேரம் ஆயிருக்கு 1 hour ஆயிருக்கு. அப்ப கண்டிப்பா இந்த டிஸ்டன்ஸ் 2 கிலோமீட்டர் இந்த டிஸ்டன்ஸ்ல பாதி. அப்ப கண்டிப்பா இந்த டிஸ்டன்ஸ் அவர் எவ்வளவு போயிருக்கணும் இங்க போன டைம்க்கு பாதி டைம்ல போயிருக்கும். That means this time should be 30 minutes. Here you have approximated. Am I right? Am I right? So if I ask you to find the same information, let's see this here. So his displacement and his time taken. Displacement and yes, Tulsi, tell me Tulsi. You wanted to say something. Yes, Tulsi. What I am not able to hear you. Can you be a little louder? Keep the mic closer. So let's see this here. Now, the displacement versus time. Displacement versus time is taken. And I'm just going to mark the entire information. Okay? When you started to observe, already that man has traveled how much? 2 kilometers that man has already traveled. When you start to observe. Right or wrong? So I mark it here. It is already 2 kilometers. And from there, he is slowly raising to the 4 kilometer. This is 4. And this is 6. Okay. So definitely he might have taken some time. Here. He might have taken some time. This is going to be 1 hour, or let me mark that as 60 minutes. Okay. Got it? So how do I calculate when he might have started? It's very simple. If you extend this line, okay, where will you reach? On the time axis, you will have some extra information, but on the displacement, you will come down to 0. So this time should be marked as what? 30 minutes. Since it is on the negative time, so it can be marked as minus 30. Did you get it? So here you get a practical condition and you can plot that as a graph. So in this graph, if you observe very closely, What I have done here, I have drawn a dotted line, right? This dotted line, this line. Let me highlight that part. This part. This part. Okay. This part is called as x-axis intercept. This part is called as what, sir? X-axis intercept.
Sir,
Yes.
sir, can you repeat the part like how it came like x-axis intercept, sir, that from 2 kilometers?
Because very simple. Intercepting means what? What do you mean by the term intercepting?
Sir,
Intercepting
intercept,
something.
sir, the line that intercepts the y-axis and x-axis.
No, actually the line is not intercepting. The line is actually connecting. If you continue to grow like this, it is going to intercept at this point.
Yes, sir.
Got it? If you grow the line from your point of observation, it is going to hit the
Intercepting the
x-axis.
x-axis.
Got it?
Yes, sir.
Yes. Noted? So put together it is 60 minutes plus 60 minutes, 30 minutes. So 90 minutes, 1.5 hours. Similarly, I can do the same for another observation. You can try that also. Is displacement and time. Displacement and time. So you start to observe from here. You start to observe from here. See, for example, this man's house is here, and your house is here, and park is here. That's the man. So if this person starts from here and goes in this direction, it should be taken as positive because like a graph. So if he goes in the opposite direction, it should be taken as minus displacement, negative displacement. Then again he comes back here. Let's imagine something like that. Okay. You just imagine. So under that condition, so here already you have some time. So when the time is equal to 0, what would have been his displacement? He would have started already here. So this is going to be his initial displacement. Yes, initial. So what do we call this line? Y-axis intercept. Suppose if you are going to calculate the time, at what time he would have started, you will get x-axis intercept. If you try to calculate at what distance he would have started, then you can get the y-axis intercept. Okay.
Sir,
Yes.
sir, but according to this, like what distance he has started will be negative, no, sir.
Now that's why it's negative.
Okay.
He see the
Yes,
graph?
sir. So according to our point of view, like he is starting
Yes,
from negative.
according to your point of view, he started at negative. Got it?
Okay. Yes, sir.
So noted. I know today you have a lot of glitches in the audio visual. We installed this new board. Just give us one day. The softwares are getting updated. So later, everything will be smooth. Got the idea? X-axis intercept and Y-axis intercept. These are very interesting way how you can explain some functioning of the graph. Okay. Noted? X intercepts and Y intercepts. And how do we write these X and Y intercepts? Now I'm going to give you geometric equations. Are you aware of the geometric equations? Geometric equations தெரியுமா? என்ன shape என்ன equation? Are you aware of that? I'll give you one simple equation here. Equation of a straight line. Can anyone tell me if you know already? Equation of a straight line. Equation of a straight line. Y is equal to mx plus y is equal to mx plus this is the formula. Okay. Have you learned this? Ever?
Yes, sir.
Where did you learn?
Sir, in 9th standard, I learned about this, in the slope.
Okay.
They told like M is the slope and C is the intercept, no, sir.
M is the slope and
C
C
is
is the intercept. That's correct. So this M is the slope and C is the intercept. Today, can you relate it? After reading the graph, why is the M becoming slope? Very simple. Let's take this C distance, this distance C, this distance C.
Sir,
Yes.
sir, I got disconnected from the meeting, sir. Could you explain the previous graph and this equation on the board?
Yes, sure. Watch this. Where did you start? Where did you get disconnected?
Yeah, this
Ready?
graph only, sir.
This graph. Okay. We ask some questions, something like this. Okay. இப்போ முதல் இந்த கிராஃப்ல இவர் எவ்வளவு நேரம் முன்னாடி ஸ்டார்ட் பண்ணிருப்பாரு அப்படின்னு நம்ம கெஸ் பண்ணோம். எவ்வளவு நேரத்துக்கு முன்னாடி அவர் ஸ்டார்ட் பண்ணிருக்கலாம். அந்த ஆன்சர் வாஸ் 30 minutes. Am I right?
Yes, sir.
அதே மாதிரி இந்த கிராஃப்ல நாம என்ன கெஸ் பண்ண போறோம்? அவரு எவ்வளவு டிஸ்டன்ஸ் முன்னால ஸ்டார்ட் பண்ணிருக்க சான்ஸ் இருக்கு. ஓகே?
Okay, sir.
So if you extend this line, observed line, and it comes and hits the y-axis, okay, and that
sir.
gives you what?
The distance
Y-axis
he traveled.
intercept.
Okay.
Okay. So இந்த y-axis intercept தான் நம்ம என்னன்னு சொல்றோம்? அவருடைய இனிஷியல் டிஸ்பிளேஸ்மென்ட்னு சொல்றோம். நாம அப்சர்வ் பண்ண ஆரம்பிக்கிறதுக்கு முன்னால அவர் டிராவல் பண்ண டிஸ்பிளேஸ்மென்ட்.
Okay, sir.
Got it?
Yes, sir, got it.
Okay. So here every observation is written in the form of a straight line. Okay. So in geometry, every shape has an equation, and the equation of straight line is written here. Okay.
Okay, sir.
And what's the equation? Y is equal to mx plus c. And here m is a constant and c is also a constant. M is constant and c is also a constant. Okay.
Okay, sir.
Okay. Now watch this. I'm going to draw two graphs. Y axis, x axis. This is graph number 1. Okay. And this graph starts from 0 and grows. Okay. Noted? So in this graph, c is equal to 0. In this graph, c is equal to 0. As c becomes 0, the equation turns out to be y is equal to m into x. Because c has become 0. Can I intercept it? Origin start ಆಗುದು. Am I right? X and y are meeting at the same spot. Got it? Suppose, what do you mean by slope? Y by x is equal to m, which is nothing but slope. And this slope is constant. And this slope is constant. Day before yesterday, you have drawn slope for a straight line. So no matter whichever the path you try to calculate the slope, you got the same answer. Am I right? Am I right? So here the m is a constant. It tells you the structure is a straight line. Got it? Got it? Suppose if the same graph turns out to be something like this. Y axis and x axis. So graph turns out to be something like this. So how will you convert this graph? Definitely y is equal to mx plus
mx plus c, sir.
definitely. So where will you find the c? Here.
Mm.
Correct? Is that right? This height is going to be this. Correct? Noted? Now let's imagine I want you to draw or I want you to write two equations for the situation I'm going to give you. Okay? Let's watch. There is a point. Let's imagine there's a point. Car A is starting from this point and going forward. Okay? Car A is starting from this point and going forward. And car B is already starting car B is starting.
Sir,
Yes.
sir, this is Trixie, sir.
Yes, Trixie, tell me.
Sir, Ria left by mistake. Can you let her in?
Sure. Has she joined?
Not yet, sir.
Okay. I've admitted both. Dharamtika and okay. Okay. So here the car starts from here and it already just started from this point. So let's say this point is 4 meters away from origin. It started 4 meters away from the origin, and this car starts from here and it moves in the forward direction. Okay, and both are traveling at 5 meters per second or 3 meters per second or 4 meters per second, something like that. You can just 4 meters per second and 4 meters per second. Okay, these two cars are moving with a steady velocity and they are going in forward direction. I want the children to plot a graph, also to write their equation. Noted? I want you to plot a displacement time graph and the respective equation.
Sir,
Yes.
sir, the before you like drew two graphs, right?
Yes.
So the second graph I got cut out of the class. Could you explain again?
Yes, sure. Now I have given you a small task. Can you try this and at the end I'll explain this? Okay?
Okay, sir.
Please try this out. Can you plot the graph for these conditions? And Ria, I'll tell you the situation here. Let's try the graph so that you'll automatically understand the previous two graphs. Okay? Otherwise, you'll go back there and revisit it. Is it okay, Ria?
Yes, sir.
So now let's see. I'm going to plot a graph. For the given situation. Fine. So it is going to be the displacement versus time graph. Got it? And I'm going to plot it for the first fellow. He starts from 0 and he keeps going with 4 meters per second. So if I take the slope of this graph, it should become 4 meters per second. No problem. So now I write y is equal to 4x. Y is equal to 4x. What's the standard formula? Y is equal to mx plus c. Since he started from the origin, for him c is equal to 0. Am I right?
Sir,
And yes,
sir, what is MNC actually?
that's what I'm trying to tell you. Okay.
Okay.
So for any person who starts from the origin, see, he is traveling at a steady speed. As you can observe here, the first car is traveling at 4 meters per second. Second car is also traveling at 4 meters per second. Correct? So when the speeds are or the velocities are steady, then the graph must be what? A straight line. Day before yesterday we learned it. Am I right? Am I right, learning?
Yes, sir.
Okay. So I'm trying to write the equation of the straight line. So what's the equation of straight line? Y is equal to mx plus c. What is c in it? At any given time, if the function does not start from the origin, it will have an initial constant. And that initial constant is called as c. According to this situation, okay, this person starts from the origin. Am I right? Harini?
Yes, sir.
Priya?
Yes, sir.
Okay. So it starts from the origin. So his value of c is equal to 0. Am I right? So here we have the data. His velocity is equal to displacement divided by time, which is equal to 4 meters per second. 4 meters per second. Got it? So in this graph, y divided by x should be equal to 4. Correct? Because y-axis is displacement, x-axis is time. Correct?
Yes, sir.
Okay. And he exactly started from the origin, so his c value becomes 0. So for the first person, we have plotted the graph. And for the second person, we are going to try. He already started from 4 meters. So let's write 1 meter, 2 meters, 3 meters, and 4 meters. So he started from the 4 and he travels. Got it? This is for the person B. Since these two lines are parallel lines, the slope for both the lines must be what? Equal. For any parallel line, the slopes must be what, sir? Equal. Got it?
Sir,
Yes.
sir, slope is y by x, no, sir.
Y by x. That's correct.
Sir, but for my graph A, I got 4, sir. Like y by x is 4, but for graph B, I got y by x is equal to 16.
Not possible. Definitely not possible. Because if you take both are traveling, because I am telling you, both are traveling at the same speed. Can you show me what information have you taken?
Sir, 1 second, sir. Sir, yes. So I have taken like B is equal to mh plus C, no, sir. Like
Okay.
m is equal to 4 and C is equal to 4 because
M is
there
equal to,
at
okay.
least
Let's write. Y is equal to, for this person, second displacement, y2 is equal to, m is equal to 4. We don't know the x. We don't know the x. Plus
sir.
C. Correct?
C is equal to 4, no, sir.
Yes, C is equal to 4. You can take that too. Okay.
Mm.
Then
So y2 is equal like y2 by x is y2 by 4x is equal to 4.
y2 by
4x is equal to 4.
no. It's an addition, right? If you bring it this side,
A subtraction.
you should go
Oh, my
negative,
bad,
right?
sir.
Subtraction.
Yes, sir, sir. Sorry, sir.
You divided it, 6.
Yes, sir.
Okay, sir. Sorry. Fine. Children, did you understand how the graphs are converted into equations? How the equations are converted into graph? Let's go back to our previous graphs for your friends and we will revisit. இரண்டு கிராஃப் இருக்கு. இந்த ஃபர்ஸ்ட் கிராஃப்ல நாம என்ன கெஸ் பண்ண போறோம்? ஒருத்தர் நீங்க பாக்குறீங்க, அவர் டிராவல் பண்ணி போயிட்டு இருக்காரு. இப்போ நீங்க அவரை ஒரு 5 மினிட்ஸ்க்கோ 10 மினிட்ஸ்க்கோ நீங்க அவரை அப்சர்வ் பண்றீங்க. அப்சர்வ் பண்ணிட்டு நீங்க சொல்றீங்க, இவ்வளவு ஸ்பீட்ல அவர் போறாருன்னா இவ்வளவு நேரத்துக்கு முன்னாடி அவர் வீட்டுல இருந்து கிளம்பியிருப்பாருன்னு அர்த்தம். There you are guessing is time taken. So that gives you x-axis intercept. Okay?
Okay, sir.
இதுலயே என்ன கெஸ் பண்ண போறீங்க? அவர் இவ்வளவு ஸ்பீடா டிராவல் பண்றாருன்னா நான் பார்க்கிறதுக்கு முன்னாடியே அவர் இவ்வளவு தூரத்தை கிராஸ் பண்ணிருக்க சான்ஸ் இருக்கு. Got it? Because you started to observe from here. You started observing from here. Got it? So when he started, he already has traveled this distance. Then only he came to your location. So in the previous case, you calculated how much time before he started. Here you are calculating how much distance before he started. Got it? புரிஞ்சுதா ரியாக்கு?
Yes, sir.
Okay. So
Thank you.
whichever the way you calculate, either you get the x-intercept or y-intercept. These are going to give you some constant numbers. These numbers are generally called as C. In the equation, these numbers, they go in the form of C. Okay?
Okay, sir.
Okay? And these graphs, They assume what shape? Straight lines. They create what? They form straight lines. Am I right?
Yes, sir.
If they form straight lines in coordinate geometry, we have equation for all the shapes. And for the equation of straight line is y is equal to mx plus c. Okay? In this equation, c is the quantity which we guessed before. Okay? X intercept or y intercept. And m is the slope. M is the slope. Got it?
Yes, sir.
So in this numerical problem, we have seen that what is the slope of a displacement time graph? What's the slope of a displacement time graph? Displacement.
Velocity.
Very good. Velocity should be the displacement time graph's slope. Am I right?
Yes, sir.
Okay. Velocity should be the displacement time graph's slope. Already that information is given to us. The velocity is equal to 4 meter per second. Am I right? So slope must be equal to 4. Correct? So in the place of m, I wrote 4.
Yes, sir.
Okay.
Okay, sir.
What is c? The initial
0.
value. Initial value. For the second person, it is 4. For the first person, it is 0. Okay.
Yes, sir.
So for the first person, initial value is 0. For the second person, initial value is 4. So here we can write y1 is equal to 4x, y2 is equal to 4x plus 4. Or you can say 4x1, 4x2. Got it? Have you written these two equations? Have you plotted this
Yes,
graph?
sir.
When I asked you to plot.
Yeah,
That's the
sir.
question. Yes. Okay. Children, sir, the sound or the visual, if it is not clear today, let the software get updated. So if it's updated, then everything else should be done. Just give us one day. It will get fixed. Shall we proceed? Okay. Watch this. Here, something called a differential calculator. We are going to use this technique to find out the velocity, acceleration, displacement, and whatnot. There are many things can be found using this. I want you children to note down these formulae. I'll explain you what is what. Okay? Just note down the formula. And this is most important of all. This formula. It's the most important formula of the all. Okay?
So once again, the copying.
You're copying? Yes. Just take down the formula first. I'll explain you each formula in detail. There are plenty of other formulae, but these are the most important ones. Just note on the formula for now. I'll explain it. Noted? Noted? See some interesting numbers from this. Copy. Take down. This is chain rule. This is chain rule. The 10th rule. Sorry, 9th rule. This should be the 9th one. This is chain rule. And then derivatives of trigonometric functions. I've written only the basic three.
Sir.
Yes.
Sir, can you scroll up, sir? 1 second, sir.
You have written up to 8. You have written up to 8.
Sir, 1 second, sir. I'm in 8th one ending.
Okay. Take it up to 8. 9th one, we can go down. Can we?
Yes, sir.
Name will start from here. Can you proceed? Take the derivatives of trigonometry and derivatives of logarithmic and exponential functions.
Sir, can you show the ninth one? So what's that, sir? AX plus B or AX into B?
Where? Which part? Which part? This part?
Next one,
Not
sir.
this part. This part.
No, next to D by dx.
Next to d by dx. This one?
That one, sir. Yes, sir.
This one?
AX plus B or AX what, sir?
A x plus b.
Yes.
Sir?
Yes.
Sir, we have to copy 9th one, sir.
Yes. So 9 formula for general derivatives, 3 formulae for trigonometric derivatives, and 3 more formulae for logarithmic and exponentials. So totally 14 to 15 formulae. I want you children to memorize and know them thoroughly. At any given time, whenever I ask you, you should be in a position to tell me those formulae.
So should we also copy the derivation of trigonometric function?
Yes. One go, you just copy that. I'll explain you what is it. The detailed meaning. Noted? Observe this. Every equation for derivatives of exponentials.
So can you go a bit up?
Okay?
Sir?
Yes.
Sir, I have to copy log exponential.
Yes. Totally 15 formulas. 9 from general derivatives, 3 from trigonometry, and 3 from logarithmic. Fine. Copy it. If you are done, tell me, children, I'll explain you what.
Done, sir.
Okay. What about others? Completed?
Yes, sir. Yes, sir.
Watch this. This is a very beautiful mathematical tool. This tool is called as the differential calculus. Okay. Now, I want you children to understand there are 3 to 4 types of any measurement that we do. So let's take the first category of measurement here. Displacement. Okay. Let's take a quantity called a displacement. What do you mean a displacement? A body starts from a point. Let's say this initial point I, and it goes to the final point F. From point I to F, the body is moving. And this body can travel in any path, something like this, and it can go to this point. Okay. But how do you calculate the displacement? Displacement is always calculated between the initial point and final point in a straight line. So that's why you call what is displacement? Shortest distance between starting point and end point. Am I right?
Yes, sir.
So here we write this as what's a displacement and this as distance traveled. In other words, this is also called as path length. Okay. So also called as path length. Got it?
Yes, sir.
So your body, let's imagine a body starts from point 1. Otherwise, let's call this as origin. First, it goes to point 1, then it goes to point 2, then it goes to point 3, then it goes to point 4. Okay, randomly I have marked a few points and I try to find the displacement here. See, I randomly have marked the 4 points. Okay, so now let's imagine this particle is starting from the origin. So it starts from the origin and first it goes to point 1. Okay, what do we call this displacement? Displacement number 1. So let's call it displacement 1. Then this starts from here and it goes to the second. Displacement 2, displacement 3, and displacement 4. There are 4 displacements now. Displacement 1, displacement 2, displacement 3, and displacement 4. Am I right? Noted? Noted? So there are 4 displacements now. Now if I ask you to find out what is the average displacement. What is the average displacement? Let's assume that the each distance is travel or the each segment is travel with 5 seconds. Okay, let's imagine that each segment is traveled with 5 seconds. Fine. So can you follow? Each segment is traveled with 5 seconds. So here it is 5 seconds. And here it is 5 seconds. And here also it is 5 seconds. 5 seconds. Each segment is traveled with 5 seconds. Okay. So totally, what's the total time? What's the total
20
time?
seconds.
20 seconds. Very good. So the time total, T total is equal to time total. T total is equal to 20 seconds. T total is equal to 20 seconds. Okay. Now I'm asking very interesting question. What is the average displacement of the body? Average displacement. Average displacement. And second displacement I'm going to ask is, what is the maximum displacement? What is the maximum displacement? Out of these 4 points, let's call this point as 1, 2, 3, 4. Which point is far away from the origin? Which point is far away from the origin? Is it point 1, point 4, point 2, or point 3?
0.3, sir.
Point 3 maybe we can take. Suppose when I ask you what is the maximum displacement, then you can connect this one and the farthest point. So this should be what's the maximum displacement. Correct? Average displacement எப்படி சார் calculate பண்ணுவீங்க? S1 plus S2 plus S3 plus
Plus
S4
S4 by
divided
total number.
total. Very good. Noted? Now comes the third information. It's a very critical information. It's called as instantaneous displacement. Instantaneous displacement. Okay. What do you mean by instantaneous displacement? At a particular time, what was the displacement? See, for example, if I ask you at 20th second, what is my displacement? So you have to draw a line. From where to where?
Origin to point 4.
Very good. From origin to point 4. So the distance, this line will give you instantaneous displacement at 5th second. Am I right? Suppose if I ask you, what is the instantaneous displacement at time is equal to 10 seconds.
Sir, from origin to S2, sir.
Origin to point 2.
S2. 0.2.
Correct? Now if I ask you a question, at what point is it possible for this entire observation to be the instantaneous displacement and maximum displacement or equal?
Second,
possible?
repeat, sir.
Is it possible for this entire observation? Fine. In this entire observation, instantaneous displacement and maximum displacement, can they be equal?
Sir, at 15 seconds.
Excellent. At 15 seconds, instantaneous displacement is equal to maximum displacement. Got it?
Yes.
Yes. So in this entire process, we learned something about this concept of instantaneous displacement, and I am going to elaborate it in the next session. What is the meaning of this instantaneous displacement? How are we going to find this out? Not just only a displacement, you can just take 1 minute. You consider the velocity. Velocity can also be written as average velocity maximum velocity, and the third one is instantaneous velocity. Okay, and the acceleration can also be written as average acceleration, maximum acceleration, and instantaneous acceleration. So whenever you have to calculate these instantaneous values, you have to use a mathematical trick, and that trick is differential calculus. Okay, got it? So from time to time, the equations may vary. Yes, Rohit, you ask some doubt.
Sir, like if the maximum displacement is like hypothetically the maximum displacement is S2 means then instantaneous displacement is equal to maximum displacement will be H2.
10. Instant means time.
10 seconds.
10 seconds. Correct.
Okay, sir.
Instant means time. Okay, at that instant means what?
So
Time.
so if S2's maximum means 10 second instantaneous displacement
At
is
10
equal to maximum
seconds,
displacement is 10 seconds.
how should you answer this question? As at 10th second, instantaneous displacement will be equal to maximum displacement.
Yes, sir.
Okay?
Yes, sir. Understood, sir.
Yes. So shall we stop here? Thank you.
Thank you, sir. Bye, sir.
Yes, I
Thank
know
you,
we
sir.
had some glitches here. Next week, we'll sort everything out. Newly
So
installed
next
the
class is
board.
on Tuesday.
Next week. Yes, next week.
Okay.
Okay, sir.
Okay?
Thank you, sir. Bye, sir.
Bye, sir. Bye, sir. Bye.
Thank you, sir.
Bye.
Thank you,
Bye.
sir.
Bye. Bye, sir. Bye. Bye.